Hello, folks. Thanks for coming on by. Today is another Advent of Code attempt. Of course, I'm like an hour away from the actual Advent of Code, so we're going to start off with an easy little Code Wars here. And then I had an idea to try and make some kind of visualization out of day one's solution. And then, of course, actual Advent of Code will be upon us. So yeah, let me set this timer up. 35 minutes, or more like 30. We'll be taking a little break before the actual code. The actual Advent of Code, not Code Wars. So many different challenge sites. Here we go. Gonna start off with this Code War. Boop. There it is. Write a function which takes two arguments and returns a sequence. First argument is a sequence already, so it's probably an array. Second is a multiplier. First should filter out all non-numeric values and multiply the rest by the given multiplier. So let's give this a shot. Our parameters are, as described, an array and a number. We should first get rid of everything that's not a number from the array, and then multiply whatever is left over by our multiplier number. I'm going to assume that the multiplier number will always be, in fact, a number. I'm going to assume the array will always be an array. They've already told us our values may be non-numeric. So here's an example. We got a null and a function of all things. And then we got a string, undefined, object array, and it's a whole bunch of them. It's weird this says multiply and filter when in reality we are filtering and then multiply. But whatever. So, first thing we can do is to get rid of all of the non-numerics, aka we want a subset of the array, returning the array filtered, and we can use the, actually receive the value as a parameter. We can use the type of operator to say, hey, if type of value not equal number, then we want to get rid of it. But filter takes things in which if you evaluate to true, it says keep. So we only want to keep things that are a type of number. After we keep all these things that are numbers, we can call them nums, we can multiply them by multiplier. That does appear to be the solution. Like I said, we weren't going for no super difficult Code Wars. Just to get the fingers all warmed up. And of course, go fun, pull out the one-liners. Same one-liner. Ooh, is finite. Because that checks both if it is an actual number and if it is not infinity, I imagine. That's a nice little way to do it shorter than this. Plus, so convert it to a number and check that it equals itself. Is finite. Okay, is finite. Seems to be a cool way of making sure things are numbers. Use a reduce, so it is not O n of 2, just simple O of n. And you don't waste memory creating a whole new array. Yeah. Seems good in my book. Goodbye. So, for those who did not catch day one, here is the basic gist of it. We have ourselves, let's not look at that. We're giving ourselves a string. Boring old string. You're gonna notice it's delimited, so like it's separated by a new line that is empty. Each of these empty new lines represents a division in the data. what this data represents is a calorie count. So 1,000, 2,000, 3,000. Then another grouping has just 4,000. Another grouping has 4, 5, and 6. Each one is a different grouping. The goal of this was to sum up all of the individual groups and return the largest number. So 7 plus 8 plus 9 is 24,000, hence 24,000 being the value, or the correct answer. The part 2 was similar and nearly identical. The only difference is that you return the top 3, which I cheated with a sort and a slice. Probably more optimal things, using like a heap or some cool data structure. I like that. I thought of one way to visualize it. It might not scale, to be honest, but I thought at least one way. Essentially, so here comes my amazing drawing skills. I'm going to render all of these as a number. So you got 1, you got 2, and you got 3. You got a blank section, 4, 5, 6. The length indicates how big it is. 7, 8, 9, and then 10. So this is a circle. Nobody say nothing. This is a circle. Now, the visualization I imagine in my head that, now that I say it's probably not going to scale well, but I want to give it a shot anyway, is that these little bars will jump on top of their compatriots. So they'll jump there, and then they'll jump here to kind of make one big bar. So it'll represent the summing of each individual group. And they'll do this for each of them. And this one's really big. It's not going to fit on screen. And then finally, that's phase 1. Phase 2 is it will kind of visualize the detecting of the largest one by marking one as green. It'll be like, okay, this is the largest one. And then comparing it to the other one. So it's like, we're going to try this one, it's smaller. We're going to try this one, it's smaller. Then when it does find something larger, it'll mark that one as large with some cool coloring, and then try the next. Now, as I say this, it doesn't really sound like it's going to scale well for the large one, but I thought it'd be a cool thing to look at, because the real estate is huge. The technology I have chosen to use is D3. For those who know, you know, it's a little bit tedious to work with. The advantage is that it lets you do basically whatever you want. What's this? Yeah, I'm gonna try Whoa Dude. My idea is that it will work with the small data, might not necessarily work well with the big data. What's this? Huh. Oh, this might be an easier thing to visualize it. Okay, how many input in, oh, there are 5, so many input files. How many lines is this? Because if I just make a bunch of dots and, like, merge them together, 2,200 lines. That's not a lot of elements. Oh, no, not that one. Whoa, dude. Yeah, I mean, there are other people doing cool stuff like that. And the leaderboards are always public, so yeah, I'm not doing that kind of stuff. I'm taking a problem and going to try to generate a visualization out of it. But I think I just found this one. I think this one's going to be cooler than what I thought I was going to do. I don't know. Because the only disadvantage about the one I was describing just now is that it probably won't scale well with 2,255 vertical bar charts. This thing I think will, though. So let's give this a shot. And again, I might not complete it by the time, but we can pick it up after the project, or after the actual advent of code. Yeah, which is why it's like, is the one was like, because it seems cool, because it kind of visually represents the algorithms, which is kind of the goal of it, but I think this will at least look cool too. Oh, you can move these. Woo, woo. Yeah, I think this will actually scale for the billions of inputs. Oh, and what I can do is I can color them. How many groups do I have? Yeah, Control D. Okay, that's already a lot of groups. Oh, jeez. Oh, jeez. Oh, 256 colors. That's actually not a lot of colors. They're like 360 degrees. Yeah, that's more than one color per hue rotation. Oh, I think this is the idea. Yeah. And then they're gonna like bloop, and they're gonna get big. Okay, yeah, I like this idea now. Okay, let's find some D3. Show me code. Overview of force layout. Circular pack. Just show code. Give code. Code. There's code. V4. Why not modern, I guess, eh? Give. Give code. Come on. Give me code. Mm. Wow. Oh, it's a bit of code. Oh yeah, and we're not doing this good at all. If y'all think, oh, this is gonna be professional. No, this is not gonna be professional code. Okay, we got code. Let's see if code works. Hey, look at that! It looks nice. Oh wow. Okay, you can't cool hover effect. Okay, firstly, this thing is small. We want full screen mega immersion. Who told you to be small? Yeah, we're not being small. Inner height and inner width. Might be too big, but look at that. We got full screen. Okay, so it is a little too much. Minus 10 pixels for our favorite scroll bar. Hope your scroll bar isn't bigger than 10 pixels. Still scroll bar. Oh, because of that thing. Oh, there's also a margin. Great. What's the thing? Box sizing, content, margin 0, padding 0, give full screen. Okay, great. That's working, and probably didn't need to do the 10. Now that all the margins are gone. Hey, did you look at that? Full screen. Okay, so now we just need to create a lot of dots. So how do you make dots? You use CSV file. Okay, what did you... Okay, well, let's not look at the CSV file. Let's look at the data. We'll just swap it out with our data. Cancel. Okay, so it's an array. We have read... My goodness. Why? Okay, let's go back to the CSV, because I didn't realize D3 injects a bunch of stuff there. Region, subregion, key, and value. Okay, we can replicate that. So let's grab our example input. We'll just go here and declare a variable. Just like we had back there. Instead of this, goodbye, CSV. You will not be missed. Whoa, Piggy Bank Studios. Appreciate the raid. I hope your Thursday has been going well. How you doing? We're over here just messing around with advent of code visualizations. Ooh, WebGL. Okay, I'm not going with those fancy visualizations, but I'm gonna trying to visualize some dots here. Oh, nice, nice. Yeah, great minds think alike. I see. Go check your channel out. Yeah, we did part 1 yesterday, and yeah, we're getting ready for part 2 also. But we're gonna try to visualize part 1, kind of these orbs. So like if you did part one, then you know there are a lot of numbers, and those numbers get added together. So I'm thinking these orbs will squish together, get big, and I don't know, we're gonna do something with colors. Ooh, parsing textures, zlib. Ah, that's interesting. I mean, I miss a little of zlib, but not necessarily it debugging it. It either works or it doesn't in my experience. I haven't used it that much. But yeah, CWASM, yeah, that's definitely a bit lower level in my experience. It does sound definitely interesting though. If anyone's curious to see some cool WASM stuff, little WebAssembly, be sure to go check them out. But yeah, we just loaded up the D3 example and are trying to put our real data in now. Which is always the fun part. Oh no. I mean, yeah, the header onlys are pretty like they're supposed to be drag and drop and plug and play as they are header only, but yeah. I mean, at some point it's either like, okay, how long are we gonna spend debugging before kind of just jumping to another library that is technically subpar on the feature list, but may actually work, right? With that 2 hour stream, I hope you weren't fighting with it for the whole 2 hours. That would not be fun. Hey, nice, nice. Okay, I'm glad you got made some progress. Oh, Copilot's doing stuff. That's a good idea, Copilot. We're not doing that. I'm glad to hear. I'll be sure to at least check in next time you're going. Let's... Okay, so what we want to do is create this const else. It's going to be input split by the double new line and map over it. Oh yeah, piggy bank. Well, yeah, I say it's pretty useful. The more contextual information you give Copilot or any of these AI things, the more they're able to help. And at least with Copilot, like the only trick you really need to know is that uh, it only reads everything above, so it can't read below. But like if I were to give this a comment, like sum all the nums in the input string, you could probably figure it out. Sometimes it doesn't figure it out. You're embarrassing yourself, Copilot. Okay, there you go. But you see, like, ask it basic stuff. It like, oh, I know how to turn things into a number. Classic reduce. The more popular something you're working on, the better it is, because it is basically just searching GitHub effectively. That's its data training. It's great for boilerplate stuff, like convert a component from one style to another. But I mean, it's worth it in my book. I'd say it's better at JavaScript since that's a more popular, like, it's literally based on the data set. So any comparative stuff, I'm going to go straight to the data set and say, well, there's a lot more JavaScript versus other languages. And it being a VS Code extension, VS Code is mainly for JavaScript, or at least JavaScript is the first class helper. I'm going to say JavaScript's going to have the slight priority on quality and tweaks. But technically, it'll work for anything, just as long as there's data for it, or you provide examples above. Split, new line, line. I also want the index. Line, index. Let's see what I want. There you go. See, sometimes it just has wild stuff, but it's enhanced autocomplete. Saves me one Google away, basically. Cost calories equals. There you go. See, like it figured that part out. Turn calories index. Sometimes it's like doesn't know some things it feels like, but still generally faster than manually typing it out. I believe if you have like an education account, you can still get the free trial. Hey, basically, yeah, it's just just a little shorter to get there. So here we go. Give me health calories. There we go, and I think there we go. Hey, of course, appreciate the raid and y'all coming on by. Prep for day 2, yeah, that's the plan. T minus 30 minutes, folks, right? It's gonna be a good one. Day 2 usually doesn't get too difficult. Oh, yeah, I appreciate the follow, too. Be sure to check out your next stream. So we have data, and I guess we want to map this into map cow and make it into an object where value is cow. Let's see if we need these other domains. I don't know about this. Color, can we just say be like random color? We want color technically by index, but we're just trying to get this thing to work. So we'll take an index, random color. There we go. Sure. The size. Wait, what's? Well, I don't know what the domain thing means, but between 7 and 55 pixels. Oh, these are the values, and this is the physical thing. Yeah, so between 0 and 14 gajillion. It's not what we're doing. We can math max calories. Or there, that seems about right. This 755 short. Okay, great. Tooltip. Didn't ask for a tooltip. Mouse over, mouse move, mouse leave. Didn't ask for any of that. Here come my nodes. So everyone gets a color based on their region. That's a lie. We're going to do color based on index. Until we figure out how to get all this to work. And great. Dragging stuff. Oh wait, do I need to do drag stuff? Nope, not for me, because we're not actually doing a simulation. Well, we are doing a simulation, but we're not doing an interactive simulation. So, watch the movie simulation. Okay, and yeah, not mouse logic. Goodbye. With height, size based on value. Where's all this region and stuff? Was that literally only for the tooltip? Yeah, I'm not seeing any of that other weird stuff. So that's my A, of course, don't work. 53. That's a cost. Make it lit. Now it's empty. Okay. Oh, give me things greater than 1,000,000. I don't have anything greater than 1,000,000. Hey, look at these dots. You can't move them, but there they are. This is good. We want to now map these to their elf to their index or whatever. So let's see. Create mapping of calories to elves. See if that can do it. Elves by cal. Nope, that's not what I wanted. AC films. I'm doing good myself. Just trying to do a quick little visualization before the Advent of Code Day 2. We got dots and bubbles. That's as far as we've made it so far. We now want to color these accordingly. For each calorie, we technically want map cal elf. So this is your elf index. Elf.index cal. There we go. Now for each cal, as we're doing that transformation, elf equals. We're not doing this transformation. Nice knowing you. Poof. value is cow. So now data is an array of objects. And now I can use color, not just D, but it'll be D dot elf. There we go. Now the ones that are, never mind. 74. Ah, it's the letter D, not I. There you, man, this is a horrible color scheme. If only they had some text on these. Ugh. Okay, I can recognize it though. Maybe if we don't do the divide by 10, it's I. Nope, that's not what we want. How does this work? I have like 5 categories. Okay, there you go. Now we can see these. So this is 7, 8, and 9. What are these small ones? And they also might not always be the same. So each one needs a unique color. And it's going to be a single color, hue shifted this many degrees. So I don't know if we can do D3. D3 color hue. Hue. Actually, no, we're not doing this. I'm doing this myself. So HSL. There's some comments. Oh my goodness, how do I do this? Oh, we'll just go to a CSS file. Let VS Code do the magic. Color red. There we go. Convert to HSL. Big thanks. Now, as I change this, we see the color shifts accordingly. And this is quite literally what I want. So, yoink. Thank you, VS Code. You big help. Color is going to be generate this little string. Right here is I. 360 possibilities, though. So it kind of needs to be ranged over this. So if there are 5, it shouldn't be 0, 1, 2. It should be scaled up to the range. Okay, so not a one-liner in my brain. Adjusted I equals I times these gotta have this. D3 scale colors. Scale chromatic color schemes. A color scale. Here we go. This is why I was a little scared about doing D3. There's so many things I don't know how to do. Arrange, and you get X many colors divided into uniform segments based on the number of values of the output range. Okay, so I can just hard code 360 things horribly. Yeah. Okay, we gotta go for an example. Example, there are 5. And I should be locked in. Thank you, Copilot. Based on number of elves. So this will be... Let's see if I can get Copilot to help me here. Between 0 and 360. Based on I and... Ooh, the number of elves. Okay, Copilot. That math doesn't seem wrong. We'll go for that. I mean, each of them should get a unique color. And let's find out. What's my input? So we have 3, 1, 2, 3, 1. 3, 1, 2, 3, 1. Look at that. And this is 1, 2, 3, 7, 8, 9, 10. Oh, this is great. Okay, so this is what I wanted. They all should have numbers. But let's take an example. Let's go to the example. So before I start throwing numbers on there, I don't want to explode this. So let's put in the big thing and see how many dots we get. Let's hope the computer don't crash. Ooh. Okay. I was not expecting a rainbow eyeball, but I am here for it. The simulation is not having fun. I will let you know. Simulation not having fun. What if we didn't do simulation? Oof, okay. Big thinking. Where is it positioning these? Because it's pushing them all together, which is kind of the issue. And where are you putting these? CX, CY, you're literally putting it in the middle. Big mistake. Big mistake. We need to randomly spread y'all out. Or features, attraction to the center. Oh no, we're not doing that. And those are attracted to each other. Also not doing that. Why are you thinking? Don't think. Collision. Yeah, that's the only thing I think we really care about. So we might not even care about that. All I want is pretty dots. They're up there. Well, what are you doing up there? Okay, we also need to shuffle this calories things, which won't be too difficult, so let's... Eh. Meh. Decisions. Okay, let's see. Fisher Yates shuffle data. Figure it out, Copilot. Thank you, Copilot. Great, so Fisher Yates shuffled them. That worked. Now, what we want to do is randomly set or randomly place. There, but we love that. Ooh, we love that. And we love that. Yes, we love this. We love random. That's a corner. That's a corner. What's up that corner? Let's turn off the simulation. Ah, it's more than one line. Ah. Man, I am bad at math apparently. It says I'm on break, but I am in fact not on break. Yeah, what we need? 10 more minutes? I guess we need 8 more minutes. Okay, this is working. And they're not moving, because that's how simulation works. A little bit performance killer, though. Okay, I'm liking this. We want to keep them somewhere on the page, though. I don't know if they can fly off the page, that's the thing. Because I don't want them to fly off the page. And now that I'm speaking of it, I probably do want them to all converge on the... What are you doing? Weird. Okay, let's get that center, whatever thingamabob I had going. There we go. One of these two. Yeah, I mean, that would be a fun thing to do in some way. Okay, force center and force whatever the other thing is. Okay, I removed the comments from this, so I can't read it. Which one is this? Nodes are attracted to each other? Nay. What if they're only attracted to themselves, though? I might be actually able to use a simulation of this to do stuff. So when they literally touch their neighbors, poof, they join. That might be something cool to do. Okay, I'm getting lost in the idea sauce there. Yeah, so this is the layout I want, and then I do want them to start merging. I want the scale to be slightly adjusted though, because as they get merged, then they're gonna start filling up the screen. So I need to actually calculate this first. So let's say goodbye, say goodbye. And there's a stroke. Yeah, we want the stroke. Good. Physical color, opacity 8. Sure, I like all that. We need to actually calculate the largest cost. Largest elf. Ooh, elf with most highest calorie I got this. Calorie total. There you go. Gotta give these good names. Bingo, bango. They do reduce. They do all the cool stuff. Wait, now my linear thing is not this to this. It is this to this. Though I might want to adjust the scale to be. Whoops. E-daisy. Ah, yeah. I'm grabbing the elf. I want the calories. Now that'll work. I said. Oh, it's thinking too many thoughts. Eh. Why you over there? Well, that's dissatisfying. My simulation thingy broke. Well, okay. Weird. Hmm. What is the elf with the highest calorie total? I know that's not how you spell calorie. Yeah, 74,000. It's not that big. Okay, let's see. D3 and top left. I mean, I think they're all going to 00XY. That's the weird thing. There we go. Force layout nodes. Did I say force? No, okay. Do. Okay. Ah, so it's happening before all things are initialized or whatever. Okay, so you initialize, do the thing, and then do the thing. So the tick's happening 1 second before it should, somehow. I have to add a on end. Yeah, and then on end, which I thought this is for animations, but watch me. You just watch me throw all the code in the wrong place. Boom! Okay, boom. That is already working better. Let's hit that, stuff. Oh, never mind. It's just not running. Awesome. Okay, maybe we'll just be baddies, write bad code, put it in a timeout. But for a whole second, it's frozen. Ooh. Maybe we just not do a force simulation. Can we be a ask simulation? Node initted and display data force nodes function blah blah blah. Weird. Huh? Uses physics-based rules, substitution elements, la di da di da. Ah, this is setting the center. Okay, so D3 force center. Spread out. I guess we're doing center, but I don't want them to be squished. Evenly spread. There we go. This is what we desire. Okay, lots of reading. I like to not read. It's a lot of reading. Okay. Okay, so we have to read. Man, they're doing real complicated stuff here. And there's not really an easy solution. I'm here for the easy solution. Space out nodes evenly. Sure, that's what I'm asking for. Yeah, I don't want them linked. Although, I do want them linked. I didn't know you could do that. Ah, look at me now. Gotten lost in the sauce again. Okay, let's just get this working. And you know, let's just for performance purposes, let's go to the easy version. I thought I deleted you. We'll have tons of fun to actually fix this. Oh, page up, please. There we go. End of page, left 3, and pasta. Okay, this is great, yeah, and we'll move that 1 second delay, then that is now ugly. Okay, so D3 force simulation on collide merge into sum. That seems grammatically correct. Okay, I'm just doing collision. D3 force. Layout collision detection. Sure. With collision I don't know, this isn't seeming an obvious thing. I thought it would be. I want to know who I'm colliding with though, not I've collided. This thing do. Doesn't seem like it does anything. Okay, D3 force layouts, JS detect collision. I want to do stuff. Read this node tick. Node set the D to the X. Here's interesting. Yes, what I get for not understanding this library. Size, blah, nodes, radius, math. I love math. We've already done math, though. I'm not doing this manually. Well, we got some dots here. Let's console log D, just because I'm curious. It's literally undefined. What's the point of this? If I remove the tick, does it not do stuff? Yeah, so you do need that. I literally don't understand this. Well, we're getting closer. We're definitely not going to get this working too soon. But I think I can make an approach happen after we do the day 2. Asynchronously force start the tick. Get the state of the layout when it's changed. Redraw the nodes and links where they currently are in the simulation. Okay. Where did I say start, though? Interesting. Center chart. Oh, on collide. This, okay, maybe I can do this. Got force, collide, and this lovely function. Take all my arcs. Oop. Oh, lots of numbers. Scary numbers. Okay, I just gotta look at the API for this, I suppose. I didn't download a new library. That's just built in, is it not? It is built in. 53 in depth. Hmm. Interesting. Hmm. Well, we are nearly there. Let me set this timer up because we are gonna start shifting over to the actual advent of code now. Where's my timer? There's my timer. Oh, why am I hearing myself? Oh, hey, and be sure to go check out the one, the only Pseudo Mateo. They just went live. Watch me typo their name. Pseudo Mateo. They are a fellow 100 dever also doing Advent of Code Day 2 right now. Doing some Rust and stuff, so get a different perspective since I'm going to be doing some classic TypeScript. You can see a different way of doing the same problem. I think they might also be doing it in Go, so sure to go check them out. Click, pause, Okay, with that, we are less than 4 minutes away. 3 minutes away, there we go. Advent of Code Day 2. Let's close all this boring stuff. Again, I'm not doing no automated download. I can make my own folders. At least for today. Whenever I don't think of a cool or a theoretically cool visualization, I will get that script working. Solve TypeScript. There it is. Create an input file, not a folder. Input file. And let's get Quokka started on this. If we drop some data here, we see data. It is working. Let's hit up a reload, just so VS Code can not be draining on my memory. Was that a mistake? It's oh no. Yeah, you got 2 minutes not to crash on your VS Code. Don't do this. Oh, you're gonna do it. Yeah, you better close. Shouldn't have done this so close. Make some tabbies over here. Need a window. Yeah, I need that over there. Can you please be quiet? There's your screencast, so y'all can see the keyboards I tippy tap. Clock is start. We're running T minus 60 seconds, folks. I was wondering why something was going slow. Something was playing in the background. There we go. Here we go. I'm gonna put this on a new line right here. A little preparation. Just a little prep. Not a lot of prep, a little prep. There we go. T minus 10, folks. As usual, I'm going to be a little quiet because focus mode, but I will try to describe the things. I love you, Spectrum. You're the best. Get puzzle input. For this example, you were given this following strategy guide. Boop, drop it there, dedent there, save it, grab the input. It's in Spanish. No, it's not. You're confused. Google. Save it. Okay, here we go. In the first round, you probably choose A, you choose paper, and it's a win for score of 8 because you choose 2 because you choose paper, but 6 because you won. Each one has a choosing, each one has a winning. If you're to follow, you'll get a score of blah 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 blah. Okay, encrypted strategy guides for A for rock, B for the elf. Must be what you should play on response. The winner of the whole term is played with the highest scores and the scores. A single round shape you selected. 1 for rock, 2 for 3, and 3. Plus the outcome of the round, 0 if you lost, 3 if you draw. Okay, great. So let's start putting these values. Win cost values equals 1 for rock, 1 for rock. Now, which one is rock? A is rock. So A 1. Then what is this? B paper is 2, 2. C3, I could have done this a better way, but here now. And we need to go through all these, at least parse them out. So data.split, new line, map align, cost A, B equals align.split space. Okay, you suppose you were given the first round, your opponent chose rock, you should choose paper. This ends with a win for you. Why am I receiving this as input, though? Second, you chose paper, you should choose rock. A third is a draw, both chose scissors, giving you a score of 3 and 3. Okay, so it is rock, paper, scissors, but with the scoring thing. So it says should, but this is literally my input. So 8 plus 1 plus 6, so it's summing the scores. So if A triple equals cost RA equals translate L A, or it doesn't need to be a translate. This is left A cost RB equals right B. 2 lookup tables, cost left. And these are the values A, B, and C. A for rock, B for paper, C for scissors. Actually, it'll be easier to just translate the right one. So leave that one there. Wrong B. Cost B equals, and then make a quick object. X is rock. Let's uppercase. X is A. Thank you, Copilot. There we go. So now we'll have that compared. If A triple equals B, return. So this is a map of getting all our totals. Giving you a score of 3 plus 3, but that's because based on what you choose. So how much is for the rounds of draw? 0. So it's 3 plus values, wrong B of what I chose. Correct, that's right. So if A equals B, all true, false, and set string, and whatever is not true. B needs to be indexed with the thing. Wrong B. Good. Okay, now if great, so if A triple equals A and B triple, so it's saying if A is rock and B triple equals B, then I forget what salt. Salt. There are cool ways to do this. I just do not know at the moment. Result equal, so they chose rock, I chose paper. 1 else if A equals, it's all 3, then it's all 6, isn't it? Yes. Rock, paper, scissors. Easiest of things, folks. They chose A, and you didn't choose. Trust it. We're gonna trust it. So there are 3 possible wins, 3 possible loses. There we go. Okay, so we're just gonna go for that. Hopefully it works. I trust you, Copilot. If result equals 1, and I have to create a score. It's based on what I've chosen. So where are my things? Values. B. It's not supposed to be there. It's supposed to be just values of B since I fixed that. Result equals 1. Score. Back on it. Score. Score is increased by score if the single round is the score of the shape you've selected. Oh, it's the values. But wait, how much win, lose, and draw? 0 if I lose, 3 draw, 6 if win. If 1, score plus 6. Otherwise, other things don't care. Turn, score. That's really bad code. But let's see if I get this right at least. Cost scores equals here. Hey, Neptune, yeah, it's basically a weird, jumbled version of rock, paper, scissors. 8 plus 1 plus 6, we got it. Turn, scores, dot reduce. Please Copilot, thank you. 8 plus 1.6 is 15. 14069. Ooh, okay, still top 1,000. Man, that was horrible code. The L finishes anyway. Second house X means you need to lose. Y means you end the roll on a draw. Exactly the same way. You figure out what shape to choose. Blah blah blah. Your opponent will choose rock, so you need the round to end in a draw. You also choose rock. Okay, so it's no longer the same thing. I love that. Because I understood so much of it in the first version. Ah. Great. This is just great. Just great. Okay, so I still have my translation layer. Well, this is what I need to do. So let's see. X leaves lose. So I can translate this. Cost if no. Stop that. If wrong B cost should. And that's going to be a translation here. So X means lose, Y equals draw, Z equals win. B, and this is should, not this. Up here, delete that. Should equals here. Okay. So if we get rid of that, I still need to do math because that's terrifying. But I can pass it down to part 1. So if should triple equals draw, then I return, show me the draw. Your opponent will choose paper and you choose rock. Okay, so if I choose rock and they choose rock, then it's 3 plus whatever value we're choosing. Ah, that's right. So okay, this is good. Else if should equals win, then it's gonna be 6 for winning, plus whatever it is that beats the other one. Beats whatever beats A. Great. Otherwise, return. So where's my 6? Ah, that's a plus sign. 6 plus whatever beats this. Whatever 2A. Okay, now these little functions are what I got to put together right now. Cost beats equals chosen. Please be cool. Oh, thank you, Copilot. If chosen A, then C. Okay, great. I'm gonna trust it. Cost whoever loses to chosen. Again, I'm just gonna trust it. Scores reduced. Right, what's my example? Total score of 12. Need to grab the input. I'm not trusting anything I've written. Sorry, I didn't write half of it. Where is it? Indent 4C, 6B. That's exactly what I wanted to see. It's supposed to be math plus values of whatever beats this. Okay, I can math that. Hopefully that looks up correct. 15 is not equal to 12. Now that you've directly corrected, you should get a total score of 12. Great, let's look at the scores. Oh, that's a broken thing there. what you're doing there. Four, 3, 8. 4, 1, 7. Wow, math is wrong everywhere. Okay, so the first one was a draw. We did that. Your opponent will choose, and you should choose. So you lose X. So console log A and should. Draw, lose, win. So if I draw that, so drawing seems to be working fine. Losing is not doing. Values of whatever loses to A. So console log chosen. What loses to A? B. So what loses? I guess that's a little confusing. What loses to? Well, come on, brain. So if I have A, what beats it? Again, I really should have done a translation library here. So if I have rock, beats it is, what loses to it is scissors, correct. If you, oh, I read the wrong one. Scroll down, read it down here. If you have chosen A, so if you've chosen rock, what beats rock? Scissors. If you have chosen paper, what beats paper? No, never mind. With my brain logic here. So if you choose A, you choose rock, you will beat scissors. Yeah, if A, get C. If paper, return rock. And then if scissors, you would hate if someone chose. Dang it, I logicked it up again. I really should have built the translation. So it's my own downfall. So if there's a rock, you don't want the other person to choose paper. If you're paper, you don't want the other person to choose scissors. If you're scissors, you don't want the other person to choose rock. B, C, A. 4, 3, 8. Ends on a lost view for score. Dagnabbit. Console log A and this. So if they have chosen B, well, make sure this didn't change. AYBXCZ, AYBXCZ. Okay, that did not change. Oof. Four, 3, 8. Values of C. C. You should choose rock. Rock is A. Yeah, it's a little. Now we're getting part two is the prediction part, Neptune. Yeah, and this is where my rushing of part one is biting me in the buttocks. Okay, so we're gonna translate it. All A's. Come on, give me selections. Oh, this is literally something I should have done before. All A's. I can't do this for the real input though. Dagnabbit. Actually, I can. All A's are rocks. All B's are papers. All C's are scissors. Data equals data dot replace / the letter A. All of them. The letter R. Yes, man, I'm literally redoing the math. I should have done this earlier. B, paper, C, scissors. I'll do this to part one too. Make sure we don't break that. There we go. What beats rock? Scissors. What beats? My brain. Okay, I'm glad nothing's broken here at least. So my translation worked. Now I can actually read this. So what beats rock? Paper. What beats paper? Scissors. What beats scissors? Rock. What loses to rock? Paper. No. My brain's doing great. What loses to rock? Oh no, I'm running out of energy here. Scissors loses to rock. Okay, thank you. Loses to paper. Yeah, cause yeah, what does rock beat? Rock, paper. Okay, 437. Is this right? No, that's 1412. Now, which one is throwing it wrong? So the wind's fine. Paper loses to scissors. Oh, it's the inverse of this, isn't it? Ah, I should have been. I didn't realize that. Yeah, so rock, paper, P, R, P, S, and then PSR over here. I think that might be it. 427. No math. Oh no, I think it actually ran. 1 2 1 2 4 1 1. Ah, there we go. Yeah, my brain just that's what I get for not doing it well in the beginning. Appreciate that help there, Neptune. 3000. It's still top 5. But yeah, rock, paper, scissors. The classics there. Man, we did make it in the end. It just took me a while for me to realize, wait a minute, I literally just write it backwards here. Definitely something to have Ankied. Okay, it's not math, it's more like logic, but it's a kind of math, right? It's just math with words. But I mean, there is the math here, like calculate the score, which was what was throwing me off, and trying to figure out which of these was wrong. When I had an error in both of them, so definitely helped to translate it and then figure it out. I appreciate it, Jack Tree. Yeah, this the second one, my brain just could not comprehend rock paper scissors. But it is. We did get there. And with this, we're gonna commit our baddie code and do some optimizations. Yeah, the score math was fortunately working. I did fortunately get that working. And that's how I knew that these were wrong, because I was confident the math was right. But yeah, we got that. There will be worse problems, do not doubt it, because once we start getting into graphs and data structures, they're gonna force you to think. There we go. Add day 22, and there we go. Hmm. Just brainstorm before I take my break. I don't think there would be any cool visualization with this. It'd just be like flashing a bunch of results and having a score counter go up. Man, I can't really think of any cool visualization here. So, yeah, we're just gonna take the break, and when we come back, we will optimize all of this, all of this wet code. Again, appreciate y'all coming on by. For those who do not know, I'm gonna get their name right. Better into this pseudo T-E-O. Pseudo Mateo is also did the advent of code. They did it in Rust or Go, so be sure to go watch them. Support them too with the always lurker. That still works last I checked. But I shall be taking my break. catch y'all on the other side. Feel free to make your way on back, folks, as the break is coming to an end. We're going to do some optimizations with Advent of Code Day 2. Boop. There we go. So we got the code working, but let's try to be anything but MVP. Or try to be more than MVP. So lots of craziness here. We're gonna start part one, of course. Yeah, this is the logic for rock, paper, scissors, winning and losing. Now, I've done this before. A lot of people have done this before, and I know there's a better way, or there's a cool trick to doing this calculation. I just gotta think of it. So let me just, now that I'm not under the clock, write this out. So rock beats paper, paper beats. Wow, that's already off to a good start. Rock beats scissors. Scissors beats paper. Paper beats rock. Right. Actually, I don't remember the old end. It's some kind of like mathy index trick, to be honest. But if these are the wins, then the loses are, as I figured out, the opposites. The values are 1, 2, and 3, which could be indexes of an array plus 1. And while I did do the translation via replace, we're definitely not going to do that in the real world. So it's going to start off with a data.split, new line. Or if I'm cool, though, I want to be cool, we can do some kind of regex. This is what regex is for, right? Let's play with some regex. Well, why not? Regex is going to be in a thing, character, space, and then another thing. I'm looking for, what is it? Not split, but match all. Let's just see what this is. Const matches. Oh, I think I turned clock off. Turn it back on. Turn the things back on. Well, that's not how matches. There we go. Hit it with the global. Okay, let's hit with the return there. Big yikes. Big yikes. Don't crash computer. Be nice to computer. Great, match all is not an array. Give array. There we go. What's matches? RX, so RY, RY, PQ, SA. Right, so it's all three examples. Great, so now what I can do here is, technically I'm summing them together, so this is a reduce. Sum, and then, well, in parentheses, sum. Oh, thank you, Copilot. That's exactly what I wanted. I guess we don't want it. We just want A out. And that's going to be P and S. Let's return sum while we're here. Provide initial value is 0. Rock, paper, scissors, which is my original input, is exactly what I get. Oh, hey, I should also be putting these back to B and C to represent the original input. I'm surprised. I mean, I'm not surprised, but that was a risky move on my play. I could have done the replacing regex, but we're living here now. So const chosen equals rock, paper, scissors. That can be put in a function. We'll get there. So who is choosing this? Am I fighting some elf? Competing against some elf? One elf gives you an encrypted strategy guide. Okay, yeah, so opponent. That's what we'll call that. Then cost my choice, or choice, and it's going to convert X as rock, Y as paper, S as scissors. Again, same three in the same order, so I could probably do some cool math to get there. Now we're gonna see const. Now we don't actually care who won. Well, we do. We don't. We care about the sorry, care about the score to generate. So it's going to be 0. So 6 for a win, 3 for a draw, 0 for a loss. 0, 1, 2. Oh yeah, it's 0, 1, 2 times 3. So loss, draw, 1. So if lost, the opponent chose rock and you chose scissors, then it's, yeah, I can see the math here. 0, 1, 2 multiplier. Multiplier equals, that's not actually correct, because if it's a lose, then it's the fail. So if, this is the part where I probably got to implement who won. And then the inverse will be determining the other way around. So function who won, 1, A, B. Thank you, Copilot. If it's draw, then it is null. We're going to keep it negatives and positives. Classic comparator. There we go. So if A chose rock, B chose paper, A won, A chose rock, B scissors, scissors won. Yeah, so we can see there are 3 generated of each. Rock, paper, scissors. Okay, that makes sense there. So now we're going to see if who won, opponent and choice equals, and 0 for nobody. So winner is who won. There that is. If now our multiplier is going to be based on this. If winner is 0, it was a draw, which is 1. Winner is 1, then I won. It's a 2. Otherwise, it's a 0. This ordering is absolutely horrible. 1, 2, 0. Very bad. Let's rewrite this. If const multiplier equals winner equals -1. Okay, I lost 0. Otherwise, is 0. There you go. 0, 1, 2. That's a better ternary. Finally, we return, sum plus multiplier plus the value of what I've chosen. So const chosen value. Oh, that's not how you do it. Or choice value. But I gave it the wrong thing. It's like, you want this, right? I'm like, no. Okay, poor thing's confused. Choice triple equals rock 1 paper. Maybe I was confused. And now it's multiplier times 3. That's how we get our victory points or whatever. Like this, 15. Undefined not equal 15. It would help if I returned this. 15, 15, and 10565. Uh-oh. Oh no, I broke that. Well, I'm glad I didn't spend this much time initially on this, because that is invalid input. Cannot find deuce. Well, it's right there. This is probably what's wrong. So, if I choose rock and they choose paper, I win. No. If I choose rock and they choose paper, they win. I think these are inverted. If I choose rock and they choose scissors, I win. If I choose paper and they choose rock, I win. If I choose paper, they choose scissors, they win. Yeah, these look inverted. I choose scissors and they choose rock, they win. I choose scissors, they choose paper, I win. It was literally inverted, I swear. There we go, 14069. It's a interesting miracle that the sample allows a reverse, an opposite game of rock, paper, scissors to be played. Ain't that neat? Okay, now for a little bit of help here, just to make this a little easier, we're gonna make some helpers. So const, interesting. There we go, whoa, dude. That's right. It was perfectly fine until we ran it against the real, and we only knew that because it failed. But yeah, what do you know? Const opponent to RPS. Opponent, come, just give me one liner. That would be cool. Thank you very much. And ternary versus an object. Ternary is more computationally better, but I suppose an object's cooler to look at. Hey Ryan, how's it going? We up here just polishing up our admin of code solution. Got a little got in part 2 with rock paper scissors logic, but we made it there in the end. Still top 5K. I hope your night has been going well, and I hope your birthday or your whatever you did that day was pretty well too. It's only a few days ago, I believe. Ryan Age plus blush. Cost choice. Yeah, let's make a mapper. So cost build RPS mapper. Yeah, it might be Friday now. That's right, that's right. So if you have A, B, and C, well, actually, we want to kind of figure out which one is R, P, and S. S, then we will return cool object R, R, P, P, and S, S, all as dynamic variables. Lovely. Yeah. It was not about chocolate sea films, unfortunately. Sorry to say. Oh yeah, make sure to check out Neptune, folks. There is no chocolate. Only coding challenges. Cost opponent to RPS, and I'll pass it A, B, and C. Actually, I call build RPS mapper A, B, and C. Lovely. This is nothing to eat here. There we go. And then we say choice RPS X, Y, and Z. Lovely. That ain't that all fancy doodle. Now here I can just say opponent. Now do I need opponent? I do not. Pass it straight to this one. Opponent to RPS. Now just pass it opponent, which is A. Then me. Apparently I do need that. Yeah, so choice will be choice to RPS. A B. Apparently these are not happy because it needs to be a little curry to function. So I need to take the car and return, not an object. I mean, I probably need to, but I need to do it like this. There we go. So it indexes the magically returned object, which math still checks out. There we go. So you have choice to RPS, winner, little ternary magic, multiplier, choice value, 1, 2, and 3. Rock, paper, scissors. I can do this, drop this down to an array, an index probably. Hey, Stephen Code Stuffs. How's it going? We're over here polishing up our admin of code solution. RPS equals RPS. So we're just going to say our choice value is values. So it's going to be our values index of choice. Easy, because that is 1, 2, and 3 indexes. Inline. Okay, let's watch this inlining for what we do want to read this at some point. Move this around a little bit. Choice winner. Choice and choice value, they can live together. Okay, this is pretty good in my book. Yeah, I mean that is kind of the challenge, Steven. It's keeping these things kind of straight and figured out. But yeah, it's challenge. Confusing people is part of the challenge. So yeah, it's to mess it up. Now, we're not doing any Project C films. It's just advent of code or a few extra code wars and stuff like that. No web dev today. Well, I mean, technically there was a visualization, so a little front end stuff, but no web dev. Great, now I gotta fix this one. Yeah, I probably should have a command for that. I don't have a command for that. Where's the about page? I'll just copy it from there. Advent. This is a great one. Command. Oh, that's too many M's. Wow, I don't even remember how this thing works. There, I think that works. There we go. Good enough for now. There's no stack C films. It's just, I mean, code is visible, which reminds me I should probably have pushed it. There's the old code. I'll get this new code up in a momento. And we do have a few new people. For those who don't know, Studio Mateo is also over there doing advent of code. Oh, you mean that kind of stack C films? Yeah, you could do that. There was a good usage of at least, or a heap map, or a min heap in the last one, but I did not do that. Yep, last in, first out. I see your Anki's treating you well, C films. Okay, so we did part one. Let's make part two a little pretty now. So instead of X, Y, and Z, it is should lose LDW. So same translation layer. Oh, could I build? No, I couldn't build it because it depends on the other value. Although, hold on. I was thinking, can we go crazy redjacks? We can. It would not be worth it though. Okay, let's start building this part out because the least bit, the first part can be done. So let's return the first bit of code. Yoink. Is that a yoink? There's a yoink. And initialize to 0. And return sum plus 1. Amazing math. Great. So yeah, so that part works easy. We convert. Nope, that's not it. Opponent equals opponent to RPSA. Great. We now know what they chose. Now to figure out what I need to do, lose, draw, win. What a weird order that is. It's the order of the scores. 0, 3, 6. Yeah. So the whole point of the translation layer was to make it easier to read rock versus paper and stuff. But since there is none of that comparison, it's essentially this here, but with X, Y, and Z. So draw is, we should do it in the correct order. So it's lose, draw, win. With B triple equals X, then this is what happens. But if it's Y, watch me do cats, then it's a draw. If it's Z, then I need to win. All we do is win. Right? X, Y, Z is win. There we go. So I had them in the right thing to just make it a little prettier. Now these things are angry because I do not have my hard-coded values. So it's, thankfully, I already figured this out. It's values, index of whatever you choose. So what I'm calculating is cost my choice. And it is this god-awful ternary. So if I'm xing, then I need whatever loses. If I'm ying, then I am choosing literally what they are. Otherwise, I am doing whatever beats it. Now, I'm not choosing A what they are, I'm choosing opponent. Yeah, I'm not using this A value. A value is no more. We don't care about the A value. There we go. Now, based on my choice, I index with values plus 0, 1, or so that's where my multiplier comes back. Multiplier returns. There we go. My multiplier. And that's literally going to be based on B. B triple equals, well, thank you. 0, 1, perfect, exactly. Oh, I could do another index, though we're here now. So this is return multiplier times 3, well, all this. Sum plus values index of my choice plus multiplier times 3. I just gotta make sure Z chose the right. Okay, looks like it did. Cannot access these functions that don't exist. Why, of course you can't. Okay, did we generate number? 12, 4, 11? 12, 4, 11. Okay, that refactor. It's going pretty good. Let's make this a little better. So rock, paper, scissors. Basically a two-way math. It's always the opposite. Trying to see if there's an order to this. +1. That's the math trick. I just realized it. It's +1 around a cyclic array. Which I can do. Watch me do this. Const RPS. That's not how RPS works. Come on. There we go. So it is return RP. Thank you. I swear this thing has a mic sometimes. Return. Now, I don't know if you can negate this. Or go +2. Okay, so if I'm at P and I go +2, I should end up at R. So P +2 ends up at R. Nice. It's not 2, though. It's not really a stable way of doing this. We should use length. But we'll be baddies. 1241. There you go. So this is the math way of calculating the winner and loser that I just could not think of. Now that I have it, though. Probably can do it up here. Part 1 optimization. Basically checking if A equals, so if I've chosen rock and they've chosen an index +1, paper, scissors, then scissors, paper, No, scissors, rock. Ah, cyclic thing. Okay, yeah, I can do that. So cost. Actually, let's let this go for a. Okay, you're not gonna do it. Cost AI. Okay, figure it out, Copilot. Okay, that's good. So if AI plus 1 modulo 3 equals BI. Right, so if going one forward. So if I've chosen rock and they've chosen paper, then I'm winning. Otherwise, I'm not winning. Exactly. Nope. 11,315. Why did you break, but the other one not break? When you're literally. Oh, you're not dependent on it, are you? No. Okay, let's just do a quick. Okay, whoa, this might be a quick. I was about to crash my computer. I can just not use who won. I can use what you should have chosen won. I'm using this index logic. Okay. Console log A B AI BI. Let's leave this for later. Besides, this is always fun to look at. A giant if else. Yeah, come on. Bring that back down on here. Beautiful. Go up there and clean this up while we're here. Let's drop this to a one-liner. And we could have co-opted this, but we're fine. Yeah, I like the index of 1. It is simple and easy. Whatever loses to, whatever wins to. It's literally the same function thing. Return offset. Const turn get choice offset. Index of care. Now, where's the offset? It's not exactly what we wanted. We wanted RPS indexing this. Index of car plus offset. Where's my modulo go? Ah, it goes right here. Boop. There we go. And it's not really 3, it's RPS.length. There we go. Now this should be choice offset chosen 1. Paste in the wrong place. And 2. Lovely. 1241 and 14069 still works. Which means I could further abstract this to literally. Oh no, I can +1. This is a Boolean difference. Ooh, ooh, ooh. So BY is the only weird one. So if it's BY, then it's this. Otherwise, it's haha, we're Booleaning this. This is great code. We're changing this code. Cost my choice. So the weird one is B triple equals Y. So then you're your opponent. Otherwise, your get choice offset. Oh, I guess we could use a Boolean. So if it's X, it's 2. So it's loses. X is loses. Yeah, that's true. I could do this. Or, watch me be a weirdo. 1 plus whatever this Boolean result is. Because false will be 0 and truth will be 1. 12,441. There we go. The code warriorest of them all. Do we need opponent? We do. We need choice? We do for readability. Multiplier. It's literally an indexable, is it not? Oh, this multiplier. ternary versus indexable, right? Indexable is more readable. X, Y, Z, index of my choice. Const X, Y, Z, and we'll make a space X, Y, Z, because no one wants that math. Yeah, nope, we're going to keep it a separate variable, not sacrifice too much readability. Oh, great, what did I do? Well, I broke it at some point. No, that is correct. So X is 0, B is Y. Oh, it's not offset by 1. It literally is. X is 0. Weird. Oh, hey, I'm glad you made it there, Madeline of Rivia. Yeah, yes, you did catch it. We're over here just messing around with some code. Advent of code, not Code Wars. Just polishing up our solution. It's a glorified rock, paper, scissors game, basically. It is Advent of Code. Yeah, look at that. Advent of Code. We completed part 1 and part 2. Part 2 scrambled my brain. Okay. Do not look at this code. This is the polished, fancified code. Essentially, the TLDR is that you're given two things. One of them, A, B, and C, represents rock, paper, scissors. So does Y, X, and Z. You need to figure out who won, and then plus them together. Nah, I'm sure. Now, part 1, at the very least, I think most people will be able to get part 1. It's just about understanding how it works. And yeah, almost forgot you streamed. Yeah, sure, check them out, folks. Fellow 100 dev around here. Yeah, support our fellow 100 devs for sure. Yeah, I mean, I'm sure I would have done a little better if it was not talking to people, but it's fun. Not always about the competition, though it is always a little bit. I mean, hey, I'm not the only one doing it too. Also Suda Mateo's over there streaming too. They're doing it in Go and Rust. Oh, that's great. Yeah, well, I'm definitely gonna catch your next one then. I mean, yeah, that's that's kind of everyone's approach. It's either okay, now that the cohort's over, I have no time, or now that the cohort's over, I have time. There's only two ways. Y equals 1 equals 2. We figure this out. Const X, Y, Z, Y, Z. Figure this out. So it's supposed to be, oh, I know what's wrong. Index of B. That was the problem. I was using the wrong one. Hey, there you go. That's probably the best way to do it, you know? Definitely gonna be the funnest for sure. Yeah, he's in 100 dev right here with the rest of us. Believe cohort 1. I mean, you were around cohort. Well, it's kind of like me. I was around cohort 1. I don't know if you partook in it per se. But yeah, Ryan's been here the whole time. Oops. Yeah, another thing. We're in weird TypeScript now. Ah, gotcha. Maybe I can do this to always return rock, paper, scissors as. There we go. Yeah, look at that TypeScript go. Yeah, I mean, I refactored I don't think I missed any of them though. Yeah, I reactified all of them as far as I'm aware. When I'll be getting back to React in general, trying to think what projects I have on the burner. I mean, I got what you call this? My always lurking thing. I'm gonna have to come back to that somewhat shortly to refactor it a little bit. So like this is the thing that you can use to watch multiple people at once. I'm gonna make this eventually so anyone can use it, not just people who care about people on this list. I don't really have any other React projects of mine. Got the Code Wars leaderboard, but that one's pretty solid. But I mean, yeah, y'all got any suggestions? Feel free to drop them. Want to see some neat stuff. And yeah, hey, I'm glad I caught you too. So now I'm glad you caught me. So now I know to catch you. Leaderboard token, Colton. Talk about the Code Wars leaderboard I just mentioned. There's no token, but are you talking about the private leaderboard? Thanks for coming on by. I'm not sure which leaderboard token you're exactly referring to there, Colton. Yeah, I mean, I don't have a leaderboard. Private one. Are you in 100 devs? If so, the Advent of Code thing. I mean, yeah, I guess y'all can join right here. But 100 devs does have its own leaderboard. If you're also in there, you can check out the Advent of Code channel. Join that one. There's gonna be more people on that than this. But yeah, why not? Worst comes to worst, I can irreparably obliterate your private leaderboard. Ain't that a fun looking button? Okay, let's get TypeScript up in the party here. Choice to RPS, B. What is B? That doesn't need to be RPS. That needs to be one of... Ooh, I can make this... Ooh, very cool. Very cool. FS. No. RPS. There we go. Watch this. R or P or S. TypeScript compels you. Nope, TypeScript does not compel me. Okay, so that's supposed to be my inputs. Oh, there it is. These are my inputs. That's not how a generic works. Pass 3 strings. You should be able to infer that. Why do you know infer? Yeah, the value is always RPS. Cannot be used. Index type. Oh, extend string. Okay. I literally can't tell until I do it all. I love that. Oh, there we go. Nice. Okay, I don't have any casting abilities here. Nope. Okay, so you'll have to do this. Never. ABC. Nope. A. B. C. X. Y. Z. Why you no love me, TypeScript? Because I'm over... Yeah. So that's not how you do that, because it's really regex, not this. Okay, well I can always... Oh man, if this is 4.9, I can do the asserts thing, but I can't. As... Oh, thank you, Copilot. As... Well, hello. Oh, great. Thanks, I do it myself. Hey, look at all these hard coding types. Lovely. Now, some of these literally I have them types in here, but they're fine. Okay, yeah, that's a nice little fun TypeScriptification. And with that, oh, rock, paper, scissors. I know I could definitely. Oh, oh. Scissors, and there you go. Loving that. Okay, I think that's all the tweaking and optimizations. I'm purposely making it a little funsies. I'll show you the raw version actually, now that I am done with this bit. Give me 1 second. 2022 date. Yeah, I have a little bit of complications just for fun TypeScriptness. But as you can see here, where is it? View file content. There you go. Okay, well, this is a lot of code, but it's just very verbose, you know? Hey, there you go. You just dream up the solution. That's the plan, Madeline, right? Yeah, so the first one was just like, oh my goodness, did you win or did you lose? Lots of just converting these letters to rock, paper, and scissors, to be honest. Do that and your life will be good. And part 2 was figuring out what beats what. So yeah, it's a little intimidating for the brain, but it is what it is. I don't know. There's not much to say, but it's rock, paper, scissors. Hey, appreciate the follow there, Colton. Oh great, TypeScript is confused. TypeScript now, come back. Yeah, this is working. Let's go check out what the Super Code Warriors came up with over on the subreddit, because by now there should be some solutions in the mega thread. Yeah, that's the plan, right? Okay, let's go to the top. See the cool people around here? TypeScript. Wow, a TypeScript came 3. Wow. Absolute lacking. Okay, so import. Let them us. They did the card code thing. The math. They knew the math. They knew the math. And then yeah, so if we were 0, then wow, okay. If you knew the math, right, folks? Yep, 1 to the winning or 2. Yeah, I did figure that out. I'm proud of that part. Interesting. Oh, hey, I'm not feeling too bad. Number 74 over here, apparently hard-coded stuff. Woo! Yeah. Oh, my. Oh, my God. Just. I thought my code was looking bad. Oh, my goodness, they wrote it in assembly. And, of course, everyone's running in Python. We love Python. Oh, no, Lisp. It's great. Perl. Oh, no. Spooky. Gosh, let's see some exoteric. Interesting. For sure, Madeline. Yeah, it's always interesting to be like, oh, it was that easy, huh? Was that easy? But yeah, it's always a good learning experience, you know, because there's always going to be more or better or different ways to do it. It's about, did you get it solved, and what can you learn from all those comment sections, basically. Okay. Yeah, there's a lot to learn for sure. Yeah, I'm sure. I'm sure. Yeah. Yeah, it's not too much of a tough one. Yeah, I did do Advent of Code last year. I can actually show you. I can actually push this while I'm here. I've done it the last few years, to be honest. Let's see. Yeah, so I did it 2021, 20. So they started in 15, so I didn't start with them, but 2017, 18, 19, 20, and 21, yeah. Been doing it for a bit now. How did I do last year? Yeah, I got one of them sub 100, but that's usually the lucky second get. I don't think so. I mean, I think you gotta be at the very beginning to get such a recognition there. Yeah, I think for the last bit here. So yeah, basically we got this part down. I'm gonna try to give that visualization another shot. Because I think I can do this visualization. I want to give it a shot. For those who don't know, it's like, what is he talking about visualization? I thought it, in my great imagination, I should throw together some kind of visualization, and it's basically the part one. So, for those who don't know, the part one was basically you would get these numbers, and they'd be in groups separated by new lines, and you would add them together. So, for those who recognize the first test input, these are three numbers that belong to one elf, three that belong to another elf. These two also belong to an elf. This one belongs to one. This one belongs to one. So my vision, my first vision was a circular bar plot. Quickly realized as I spoke it out loud, it would not work with 256 elves and thousands of bars. This I think it could work with. I'm just trying to figure out now. So where we left off, we got these cute little orbs. They're boring. They're static. We want them to kind of like bloop, merge. Want them to merge. So we want them to be attracted to their own colors. So using D3 because I enjoy pain, apparently. We're gonna try to get these things to go toward each other. Yeah, for sure. It's very much a weird disconnect. Yeah, of course, of course. It's like, oh yes, we're being super serious about these elves and their calorie counts and their pancakes and the algorithmic complexity of rock, paper, and scissors. The weirdest topics of the most seriousness, yeah. It's like, okay, is this what you're gonna write your PhD on, it feels like. Yeah, why isn't this running actually? Oh, it is running, but there aren't that many orbs. Add more orbs. More orbs. Okay, let's give you a bunch of orbs. Great. Now, where's the whole attraction-y thing? Center, charge. Right, so let's figure out D3, force, simulation, documentation. And see how we make the balls go toward each other. Like something like this. All circles attract to another. Collision detection. Circles attract to one of three centers. Ooh. Okay, so for however many elves, I can create a bunch of home pages. So like if there's two elves, it's two, but if there's three, then it's a triangle. If there's four, then it's a square. If there's five, then it's not really a square. star. Okay, yeah, so I can do that and create that many different attraction points. Hey, appreciate the stretch there, Madeline. Let's check out this code pan. Oh, X center, yeah, generating that's gonna be fun. How lovely. Yoink. Yoink. Show me my code. Okay, so there's nodes, you make nodes, random radius, random category, force charge 5, force many bodies, strength 5. Well, they have 1. What's 5 look like? Ooh, they hug. They're hugging. They're hug. No, what are they doing? 50. I guess it's just making them attack each other a lot. What if I hit 0? Okay, I literally don't know what this thing is doing. We'll put it back. Hey, 5 shaded shapes are pentagons. There you go, right? Penta for 5, right? Then octa for 8. Deca. No, wait, deca's 8. Ah, dang it. Well, they're numbers. But yeah, hey, I'm glad you learned something. Although, I don't think that's the most useful thing to learn, but there you go. Force X, X, D, D category, X center. Force collision, return radius, tick, tick. So select them all. Man, I do not understand how this thing. Again, so I get for not learning this library. On tick, ticked. Interesting. So this is forcing the X position. I can also force a Y position. It's not really forcing. That's just saying go in that direction, though. Interesting. Okay. So let's do two. Well, let's do 5 positions. 5 random positions. That'll be the way to do. Ooh, here we go. Boop, boop, boop. Up here to my data. Now all my elves, and then here we go. Const elf. Then X. We want a random one. Math.random times width and Y. Perfect. So you get a random X and Y. Congratulations. Now, based on which elf you belong to, you're going to go to that elf's X and Y. Okay, we got this. We got this. Do you have a semicolon? Good. Force X, D3. Force X. Ooh, it loves this. Unfortunately, L's is not a map. Probably something I should do. It's something I will do. So we got L's. Map. I might as well make this a reduce. First parameter, map. There it is. Cost, elf. Hello, elf. Map.set, turn map, and initialize map. And then for everyone who needs to use elves, you can probably pull out dot values. Yes, you can. And that should be all your elves. Okay, you need size. Does anyone else need the elves? Great. Dot get elf that is index perfect X. Now there was something else around there, but we're not gonna look at that. Oh, wait a minute. This returned a thing. I am returning a thing. I'm doing it with an arrow function. You're everywhere. Well, what are you doing? Is there an error? Ah, there's error. Force X dot Y. Well, that makes sense. It needs to be force Y. Y. Hey, look at that. They each have their own little home page. Their own little base. Okay, this is progress. I don't know how it's going to work for thousands of them, but we're not there yet. And what we want to do... That's the thing. I mean, I don't know. I kind of wanted them to. Well, they are found together, so this does actually make the most sense. Yeah, I don't want this center forcing code. I want them to hug each other. Oh, this is looking good. Strength 100. Okay, okay. Summon Cthulhu. Let's not go for strength of 100. There we go. Oh, I'm happy to hear that. Just trying, just thinking out loud mostly. This thing looks like a foot with an extra pinky or whatever. Yeah, it's starting to look like I want it to look. Whoa, dude. I mean, it's not doing what I want it to do. What's iterations do? Let's run 10 of those. Okay, it does literally nothing. That's what my brain can tell. Crank up the strength. Oh, wow. Okay, it makes them really sensitive. We don't want that. Okay, let's give it the real input and see if we don't crash my browser. Don't crash the browser. Who's a crash browser? Not you. Yeah, well, dude, it can be fun playing around with these for sure. Okay, lots of thinking. Oh my goodness, it's actually somewhat. Wow. I can't remember what this reminds me of some, like bacteria or things like what you see under a microscope, blobs of stuff. Or Civilization 5 actually, yeah, it's one of those maps. Okay, so it did try. What I'm imagining is happening here, since I'm choosing randomly, they are not evenly distributed. So I think what we want to do. So we want a more even distribution. That's one thing we'll want. Then I have more real estate. This might look a little better. I'm not a fan of them coming in from top left, but I don't think there's anything I care to do about that. Would you look at that? Yeah. Okay, so we want random. Just no. We don't want random. We want stable, even. Generate even coordinates. What is this? On plane, evenly spread out in coordinates. Oh, I can't imagine. Yeah. Ooh, randomly but evenly distribute nodes on a plane. That seems right. Oh, jeez. Whenever you get an algorithm that's named after someone, you know you're in for a good time. The easiest way, generate random, repeating if touching or overlapping. Well, that on a grid. Oh, a grid. Yeah, I could do a grid and just generate the correct even number of rows and columns. Okay. How many elves do I have? Yeah, how many elves are there? Yeah, 257. So 257 divide 2. 128. Oh, that's not how that works. Two 5 times 5 would give us 25 positions. But I need math square root of 257. 16. 16 by 16. Okay, so yeah, 16 by 16 will give me 256 positions. Now, I just said 16 by 16 because that's a square. It's not going to be a square, which is going to be awkward. I think this is good enough, though. Ooh, NFL stats, yeah. That's the thing, whoa, dude. With great power comes great fiddling about to get it to do what you want. Because that's what's gonna happen. Like, D3 is the most powerful yet manual visualization library out there. You can do literally anything with it because it's actually pretty good. It's all SVG, so it's not like some wacky canvas. It's literally all HTML it generates, but whew, you can do anything you want with it. But you have to usually do what you want with it. Yeah, it's a bit involved. It's not a it's going for Java levels of verbosity. It's very verbose in what it says. And I don't understand half of it. I'm just, as you can see, just trying to find examples and yoink stuff together. I'm sure, like, an actual D3, like, it's an actual, basically titled position, visualization expert generator or whatever. But the design for the actual visualization always gives enough. Domain 0. Isn't this the minimum value? Yeah, wouldn't this be math dot, well, hello world? Okay, we're not about to go changing that. Okay, we love this. So we need to generate our random points. So we have a number of L's. We'll give you all an X and a Y as we get there. Generate a grid of coordinate positions for the L's. Let's see what Copilot does. Grid width. Oh, there you go. Grid height. Okay, okay, I like this. I like this. Calculate. Okay, okay, we can stop now. I just want to show me the grid. I'll open the console. I want to see the grid. Okay, I know map is big, but show me map. Boy, this is literally okay. Do I have to multiply this? Uh, Great. It's making me do math. Generate a grid of coordinate positions scaled to the window size. Try it again, Copilot. Oh wow, whoa. Okay. Now you're changing stuff. And what were we about to do? For the ingredients. Oh, we have ingredients. Copilot's gonna make me a meal, apparently. Okay, you tried really hard. Generate a grid of coordinate positions is transformed to X and Y coordinates. Come on, Copilot. Okay, let me try to manually figure this out. So say it's 2 by 2. What do I want? I want 0 plus 1. So yeah, window dot inner width, right? So we have this. Say it's a 2 by 2 grid. I want this divided by 2 divided by 2 to get the middle of that position, because we're looking for 2 by 2 grid this. The X needs to be here and the Y needs to be there. So it's width double divide 2 to get 0. And then the height probably right. So what's that called in math? Sure, it's a name to this. They got names for everything. What if it was 3? 3, 3, 3. Nope. So that got me the coordinate I liked, but now 2, 2, 2. Oh wait, 95. 190. It'd be nice if Cobalt could do this for me. Generate grid of X and Y. Coordinates based on window size. Oh, it was going for an array. I just messed up grid width, grid height, grid X, grid Y. Okay, this seems like something, and then you just went off and did that. $100. There we go. And each one is going to be X times grid X. There we go. We need the multiplication here. Y times grid Y. I think this is what we want. I do not care about center. I just want a bunch of positions. Right, we care about the values. Come on, show values. Okay, this seems right. Okay, so I want to calculate this based on this. Cost grid width equals math.ceil. Hopefully Copilot remembers how to do this. Perfect. And cost grid height. Doing it a different way. I don't think I'm okay with it. Now for these grid positions, I just need them in an array. I literally do not need them in a map. So, grid, you are now an array. Congratulations, you've been downgraded. Come on. Grid push, well, you're not that downgraded. Now once we have the grid, we're going to go through all the elves and give them all a lovely home page. So, or cost of value of elves values. Congratulations, elf. We also need an index of this, so we need the index where symbols go. We'll use values. We gotta convert this to an array now, so I can get my entries out of it. Because we need to grab the... Oh, elves already have an index. Didn't need to do that. Should have read the code. Reading code, that's not what I do. Now, every elf has a home page based on the grid. Now, someone's going to be in the corner, but should be fine. Well, this shows I don't have a diversity of colors enough. Interesting. I mean, it's something. What's it doing? So, maybe I mix up width and height. Maybe that's... Yeah, maybe the width should be the height. It's just square, because I don't know what it tried to do for that. Be square. Nope, still going. Okay, it's literally look at my lovely elves. Look at all the fangs. How did it get so... Oh, yeah, I guess I should randomly... I should do some shuffling at some point to avoid this weird alignment. Yeah, I have a shuffle somewhere around here. Yeah, I'm shuffling the calories, which doesn't actually matter now that I don't do anything with the shuffle data. What I would like to do is shuffle the grid position. So Be sure you ate Shuffle Grid. Thank you, Copilot. You fun. What do I have 4,000 of? Grid positions. Hold up. Wait a minute. There are 200 and something elves. That's not supposed to be that many. That's not supposed to be that many. I don't think that's supposed to be that many grid positions. Oh, look, it's actually... Oh, would you look at that? So I saw the visualization go way further down right. But look, everyone's getting their own little spot. Now, why is it so freaking big? Something to do with the 4,000, I bet. And I shuffled it. Yeah, would you look at that? They are way too big. So I did a multiplication. Was I supposed to do addition instead? I don't feel like I should be doing addition. Yeah, great. Singularity. We love singularity. Maybe we're not supposed to do math. Math is bad, as they say. No math. No, we need some math. Okay, no, now we can't actually shuffle the grid because I can't look at the thing. Well, let's get the grid height, grid width, and grid height. Come on, you. 17 by 17. That's right. And it's inner width by this, so it is basically 1920 divided by 17. Each one gets 12, right? 112. So 112 is 0. Yeah, that makes sense. 2 times 1, 2, 3 times 17. That's how math do be working. Okay, let's look at the grid then. How'd you get to 2,000? How'd you do that? X is less than grid X, which is 112. Ah, you're going too far. You're supposed to be hitting up grid width and grid height like that. Okay, that seems better. My brain likes that. Oh, look, they're staying within the thing. Oh, this is it. Look at that grid. Hey, look at that. Okay, this is looking good. Hit for full screen. Okay. Oh, yeah, because the whole height thing. Yeah, it's a grid of blobs. Don't we love it? Now, we get some weird corner fun. So what we're going to do to each of them is add grid X divide 2 just to get out of the corner. I think that'll math it. Because you can see we got padding here and down here. Yeah, we got blobs. Hey, look at that. Margin center, basically. The heck happened? What happened here? Someone else figure that out. And you know what? There actually aren't that many. I mean, I know 255 is a lot, but they all kind of fit on the screen. Let's make it a small screen. So if you open this on your Samsung smart fridge, let's see what happens. I saw worse. I imagined worse. Okay, so now what we're gonna do is get these actually blobbing and merging together. So I imagine what 255, 255. Well, if each one takes a second to bloop bloop bloop, it'll take 255 seconds, which is like 3 minutes. I think 3 minute animation is more than fine. Now to actually do the merging. So I guess what I could do, just to be lazy, because I want a cool animation where they like join together like actual water droplets, but I'm not putting myself to that standard. I'm gonna just grab all of them and say delete and then recreate a new orb with their combined sum. We do that 255 times. So I think that's just going to be right on down here. Quick and dirty async function. And we'll just go through all the elves. Probably, yeah, the order. My brain is going to say some kind of cool order, like of something, but let's just get it working. Cost elf of elves values. Ooh, what are you doing? What did Copilot just suggest? Let's do that. Copilot got a suggestion for us. What you suggesting, Copilot? I literally couldn't see it because the animation was still doing animation stuff. Do the thing. There we go. We have to wait. I ain't waiting for no one. That would help if I knew where this animation was going to happen, too. Okay, do the thing. Oh? They all just shrunk. Alpha 1 restart. Okay, I'm guessing... Let's do it again. Oh, it's restarting... Okay, it's restarting the animation, which is forcing them to get closer together again. That's neat. I wasn't asking for that. That's cool, though. What do we want? So we want to get all nodes for this elf. There we go. Nodes, filter, data elf equals elf index. Good. Get the center of the elf. Sure. Elf x, elf y. Get the center of the nodes. Yeah. Okay, you were doing math. Get the distance between the two. Okay. Get the angle. Oh, we're about to do some crazy math. Get the angle. Oh, no. No, we're just gonna get some angles. Okay, I thought that was gonna be something cool. Never mind. Copilot really took me down a rabbit trail there. But yeah, we have the nodes. We have the center of the elf. Center of the nodes. Yeah, this is more the important one. So we want to say, okay, all you nodes, we're going to replace you with a new node. So, delete, or it'd be cool, merge nodes into one. Merge node is the whole value. The new center, hold on, center of nodes, divide nodes. You just wrote this, Math Copilot. How are you? Oh, this is a sum. That's literally not a center. You just summed them all together. So that's why you had to average them out. Okay, weirdo. Remove nodes from, no. Delete nodes from, no. We delete the node. Wait, what is node? What's this variable I put this thing in? Ah, here we go. So const nodes, great on naming. Delete. No wonder it couldn't do it. Variable name was off. Delete elf nodes. Remove elf nodes from DOM. Hey, we love that. I'm sure that's right. Create new node from merged node. Sure. Add new node simulation. I didn't add it to data though. Are you? Um. Oh, the simulation contains. Actually, the simulation is dumb. How does it? Oh, this is how it is. Okay. Hey, that's right, C Films. It is a runtime environment. Add new node to simulation. Can you try that again, Copilot? Please try again. I don't feel like that's right. Gonna trust ya. Update simulation. There we go. Make you tick. And then let's return. And let's see if this... Wow. Oh, I refreshed that really too quick. It kind of did a thing. Why are you angry? Why are you angry? Oh, nodes. So I changed that. Please don't crash my browser. Thank you, good sire. Is there a way to fast forward this? Because I would love to be able to fast forward this. Do the thing. Oh, look, we got a red one. It's making red ones. I'm seeing a significant lack of deletion wherever it is. Loving that. Remove nodes from simulation, right? Move nodes from DOM. Any errors? 18, but I don't think those are mine. Ooh. Okay. Simulation nodes filter out those. Great. What's up with this color, by the way? Color of the elf. Color of D. Elf index. I mean, so log merged node. See why that not look cool. Okay, I think we're about to drop this data set real soon. Elf 0. I don't know where Elf 0 even is. We're making big red circles. All red circles. All Elf 0. Oh, okay, so the first one, no wonder that doesn't work. Yeah, it's not able to because we keep hitting the 0th elf. Why is it getting a position though? That's not good to know. Ooh, because I'm filtering on data. Yeah, we'll try not to dream of code, right? Of course, Ryan, I appreciate you. Have a good night, yeah. Oh, data filter. I just want to get rid of it out of data too, I suppose. Move nodes from data. Yeah, because that's what's catching lots of this on fire. Let's simplify the data set. I mean, that's not too different than most of everyone else. Learn. That's definitely, happy here to learn. Get a job being the end goal, obviously. Got my networking skills were still aren't that great, but they're better than they were than I started for sure. And also, it's a pretty just great community to help out in general, and great community to just be a part of. Never really had that before. I wish I did, but definitely great that I got one now. Oh no, it's on fire. Interesting. It made a bunch of dots. Yeah, yeah, I'm in the cohort. Cohort 2. Oh, yeah, I mean, I do help, but because I got a little bit more experience than most, but yeah. Joined cohort 2. Technically, I joined like the last week of cohort 1. It was basically over because Diabolical or James Corbin, who recently did a tease spill, they were also streaming. So I jumped in their stream and I was like, oh, this seems pretty cool. And they were like, 100 devs is over. And I'm like, well, that sounded great. 100 devs is coming back. Well, I should join. Definitely a lot more attractive looking than college, considering it was COVID was all doing its thing, and all the scholarships basically ran out since COVID dropped it all down. Okay, what if we didn't do a simulation? I don't know which thing's failing here. So turn off the sim, unplug the simulation. Oh, why does not work? 113. Ah, wrong symbol. Yeah, yeah. Do the thing. Nan. You love to see the Nans. Oh yeah, I mean, yeah, I was looking at a couple of them too, like that Flatiron one and stuff, and a couple others that I was seriously considering a few of them because they all looked a lot better than college, considering the price tag on that. There you go. Yeah, a lot of people came in on that Reddit post. Whole shebang of them. Oh. Okay, now why is this not working? For such a simple idea, I don't want to go ranting on D3, but for such a simple idea, I have made progress, and I'm not really D3 expert, so I guess it's pretty alright. Figure out why this ain't failing, though. So console log merge node nan. We hate nans. So data, these are the nodes of the elf, center of nodes, reduce, node x, node y. You would think that would be right. But console log center of nodes. Maybe that's wrong. Do the thing. Center of nodes is neither x nor y, which means node x and node y are dumb. Because these are data objects. How do I get the nodes? I want nodes.nodes or whatever. Get from nodes. Thank you. My goodness. This is what you get for trusting Copilot all the time. Hey, of course, Madeline. Yeah, it was great catching you too, and I'll definitely be sure to catch your next one. Yeah. Elf nodes not defined. I swear it is. Yeah, I'm pretty close. I just gotta figure out what exactly I need to do. Which isn't all the problems, right? And I have the idea. Just gotta figure out the code. Okay, promise. Oh, these are paths. It's not what I want. I have to pull out the data. No, I have to get your CX and your CY, don't I? Great. We will get through this. Oh my lord. What tarnation? Oh, because it's no, that's dumb. What the heck is this? Since when did HTML elements look like this? Well, what SVG tomfoolery am I looking at? Okay, we're done. We're not doing... This is a raw node. Get Yeah, can we do that? Be like normal JavaScript developers? Yay, there we go. Just give me string. Wow, SVGs. Didn't know they did that. The more you know, folks. SVGs, you want to read an attribute? They're going to give you an essay to read. I'm sure is good for stuff. There we go. We have all that. Then we're going to hit up a reduce, which you can't do on a string, on a weird thing. Then it's node dot double underscore. It's a dunder method. We're back in Python days. Hello, it's a dunder method. Or a data model method. I don't know what they call those now. Merge alpha nodes into one. Remove from the DOM. D3 select remove. Yep, that's what we need. Remove nodes from data. We're not using data, it's too low. Create the new node. This should throw it on the page. Moment of tooth. Now they are all randomly assorted, so we're not really going to get lucky. Of course, for each is not a function. Elf nodes. Maybe that's all we need. Again, learning a library, folks. Oh, look, it did. This is on a loop. Well, I just double ran it. That was a great idea. Poof, poof. Put the blues all in the middle. Yes, yes, yes. Oh, I think this... Okay, so simulation be darned. Okay, but we gotta turn the simulation back on. Great. Turn on the simulation. This is gonna be the part that's gonna really be tough to figure out. Okay, one at a time. It's putting them in different positions. Very different positions. Is it even adding them back to the simulation, though? Alpha restart? Maybe that's what we do. Because they're not going where they're supposed to go. Oh, their current location isn't what's being simulated. It's being simulatedly represented. I get it. I get it. It's a little painful. I have to figure out console log. Center of nodes and merged node. Yeah, so I'm seeing blue. You're in the positive and the half. This one. Oop, there we go. We love ourselves a nan. Well, X and Y were a nan and a point. Let's look at this. Elf nodes. Guess you don't have lengths. What am I logging? Well, someone has a nan. Oh, that's all I know. Someone messed up. Where's the nan? Oh, thank you, Chrome. You took it away from me. Probably should put more data on this. And just for readability, let's crash this party quickly. Yep, so center is 27 X of 20 below my freaking monitor and a Y of... How does that make sense? And an X and a Y of there and there. X to doubt, folks. Big X, big doubt. Yeah, let's not remove them anymore. How about let's just no delay tags? Also, no delay tag there. Yeah, no delay tag. We'll keep it here. Great. Okay, so I see 3 red nodes down here. X54. Yeah, all your X, Y, and Z seem neighborly, as expected. And then you come out here Weirdo. Okay, now we didn't console log this. No, so I can't actually validate. I can definitely see this ain't the truth here. Um, well, I can look at the CX and CY, see what the values are being spat out as. See who's lying. Clear that. Do the thing. Let's start from the top. CX, CX, CY, CY. Good. 135, 7116. So that is, well, it's literally math it out. 135, 137 plus 116 divide 3, parentheses first, is 129 as expected. And look at all this stuff spat out here. 389. Center of nodes y minus elf nodes length. Yeah, there are 3 of them. Hey, Razzle time. Yeah, we're doing a little, so we already did the Advent of Code problem for yesterday and today. What I'm doing, and I'm trying to at least, I'm trying to visualize yesterday's Advent of Code problem with D3. Because if you don't know, it was basically, you have a bunch of individual values that belong to a group, sum those values together, return the largest of those values. So, I'm trying to do that with D3. I'm learning. I'm learning a lot of D3 stuff at the very least. Hope your night's been treating you well, or whatever time it is in Thursday or Friday land. Yeah, right now I'm just working on the averaging. I think I'll just simplify the data set even further. There we go, we have one node. It's way down there. What's it doing down there? Yeah, it's supposed to be up here. It's supposed to pop over here. So that's why I'm mathing my way to victory. What the heck's this random thing here? D dot X, D dot Y. I swear, if that was it the entire time. Nope, that's not it. So merged node has an X and a Y. Maybe if I just don't. Oh, there's 0. Nan. Did I do a nan? I probably did a nan. Merged node X and Y. I'm gonna make a copy of this. So I keep seeing velocity and stuff getting chucked on here. Ah, there is a number. So if elf nodes doesn't have length, is that what's up? What's with this D3 data structure we're fighting? Where is it? Elf nodes. There we go. So yeah, you're a whatever the heck you are. Pin a true call. I swear you don't have a length. Ah, the pain. The pain I feel. So painful. And look at that. It shows up where it's supposed to. Amazing. Who would have freaking thought? Kind of structure is the same. It doesn't have a length, doesn't have for each, it doesn't have anything. Great, now let's turn the simulation back on. Actually, I don't know how this is going to work. Remove nodes. I actually have to do removals, yeah. Lots of removals. So that was the next thing to test. Oof. Okay, let's clean up these consoles. Good width, good height. Got lots of consoles clean. Look at all these cancels. Finally, let's grab a sample input again. Not that one. This one. And see how she goes. Boop. Oh, I said boop. There we go. Let's see how this comes together. Nice. Okay, so they did its job. Okay, it's time for the real input now. Now, I could do a nice order of base top, left, bottom, right, but we ain't there yet. I'm really curious to see if the simulation holds, too. There we go. The simulation is literally not being activated. And they're all red. Are we just unlucky? What color is being decided here? Or how am I selecting color, rather? Fill color of the elf. Yo, why do we have no giant blue circles or purple circles and cyan circles, so? Wait, how was color originally chosen? Fill color of elf. Now, how am I calculating color? It's over elf's size. I'm not decreasing the elf size. Elf size never changed. It's a map. Unless we're just being heck unlucky. Okay, I love this randomization, but we are not doing this randomization. We are going to first figure out how to get the simulation back online. Add new node, simulation nodes. On tick, that's probably what's missing. We're not telling it to be cool and update. Ooh, untick nodes. About to see if that's the bad or the good. This reminds me of the hexagons thing in D3, which might be easier to hit. Oh, never mind. I thought there were hexagons in D3. Yep, not seeing the sim. Yeah, second delay is a bit large now that I'm seeing it. I would like this to be ordered, so we're not going by elves. We are going by grid, but we want to unshuffle the grid. Ooh, I forgot about this big string. Big string. Big string. Can you collapse string? No. Okay, we're going to manually fold you. Good old VS Code custom regions. Now we can scroll all the way back up. Last time we do this, thankfully. Dang it. How do we do regions in VS Code again? Oh. You know, I'm not gonna put too much effort because you can already see computer not enjoying it. Hey, intelligence, how's it going? We're over here visualizing Advent of Code Day 1 through grid positions from top left to bottom right. But yeah, as you can see, we have this cute little animation. It's making a bunch of little dots That's combining the small ones into a giant big one. Yeah, everybody about Advent of Code. It's fun once a year, right? Come on, you gotta do it once a year. Yeah, this is the visualization aspect of it. It groups all of the numbers for a particular thing and it puts them in these little grid oriented things. And right now it's just turning the small ones into big ones. What we're going to make it do is go through. I mean, I don't know, I'm kind of figuring out how I want to do this. Because we're getting to the creative part of the problem. Yeah, yummy fruits of code. We can see my computer's already like memory leaking somewhere, but once they do, I'll go where they need to go. Yeah. There they go. And see, they all go to their home base. Yeah, yeah, it does look. Now, for some reason, they come from the top left corner. I don't know what that is, but eventually, I'll get them to come from the center and stuff, and then do the thing. Goes through all of them and kind of boop, makes them pop, join together. Right now, it's just doing them one by one, but eventually, like a water droplet, like they'll all join together and it'll be a whole thing. And the final stage of it, which I'm feeling like I'm not going to necessarily get to tonight, is that you'll find out which of these is the largest, which is the quote answer and all that. But yeah, it does look very nice in its current state, which I'm more than happy about. Considering I love D3, and it's an amazing library, not at all confusing. That's the power of D3. You can do anything, you just gotta figure out how to do it. Yeah, intelligence, 100 devs, cohort 2 finished a few weeks ago, it feels like at this point. Yeah, now everyone's just on the hunt. Leon's getting stuff ready, possible for the cohort 3. I'm still hunting, still hunting. I technically have had one fully successful interview. They just didn't have a position available, even though they were interviewing. So, it's progress, but not hired just yet. Making sure everything is all polished up for January, though, when that wave opens up. Yeah, this does actually look nice. Some kind of weird cross-stitch pattern thing. What's up with this one? What are you doing? Weird. Very weird. Okay, Copilot. Um, I mean, if they'll take me, sure, but that's not really I'm not really prioritizing Fang. More than happy to take the pay cut for good hours and stuff like that. Index goes X plus Y grid width. That's not how it works. Bad Copilot. Who's a bad Copilot? Yeah. I'm going for any role, really, honestly, whoa, dude. Like Leon says, it's the first one that's the tough one. But yeah, I'm none of them. I'm not looking at any role and being like, oh, I'm not gonna apply to that. No, I'm good. They're all. I'm definitely. I mean, I'm networking into all of them. I'm messaging all of them. I don't care how senior, junior technology. I'm shooting my shot everywhere. Yeah, intelligence is all about that networking, though, right? So I have a grid somewhere. I can sort this thing. Cost, orig, grid, grid. There we go. Now I can loop through this. Yeah, I mean, like I said, first one's the tough one. After that first one, I'm sure I'll have a bit more leverage. That's not how position works. Darn you. I have to go find all the elves. Great. So, eh. Elves values, find. Perfect, there we go. Now that we have the elf, we can do all this fun stuff. Boop. Boop. Boop, boop. Okay, let's see if we're lucky. Let's probably turn this thing down. It's the colors I want randomized, not the positions, I'm realizing. Okay, this one's having a little struggle party. Come on, get off the struggle bus. There we go. Oh, elf is undefined. Okay, I guess some of them do not actually get positions. Oh, because it's 17 by 17, there are going to be some empty holes. Gotcha, gotcha. If no elf, continue. That sometimes happens. Okay, let's figure that out. Sorry, brain got lost there. Yeah, we want to randomize the color, not the, whatchamacallit. Yeah, color. Which is based on the index, which we don't want it to be based on that anymore. We don't want it to be even, though. We want it to be even. So... you know what? I don't care about colors that much. Just work. Just please work. Just work. Are we Fisher Yatesing anything else? Fisher Yates the grid, which means, yeah, we're not doing this random shuffle. It was an 8. We don't actually want the shuffle. We don't want any shuffles. We want top left. We want some kind of order. And yeah, since I'll randomize the color later, it's not too hard. Oh, it's vertical first. Well, that's awkward. There they go. Yeah, this does look kind of cool. What's with the weird intermittent delay, though? This does look kind of cool. It's just looking. I think I got my X and Y's crossed. Okay, now we just gotta get that shuffle of the color going. I'm curious what this big purple's one gonna do, actually. Come on, big purple. Why is it jittery? Man, I know the simulation's not doing anything. Okay, I'm glad to see that the lone ones, like, watch. It didn't actually change. Great. Okay. So yeah, they're going the wrong way and the color's all mixed up. Would like it to go the right way though. Top left, bottom right. So let's... Okay, not the input. Don't look at the input. Stop looking at the input. Hopefully I can just swap X and Y, right? Swap it by putting Y on the outside, X on the inside. I think that's the trick. Oh, there we go. It's horizontal. Now, hopefully it's top left, bottom right. Oh, it does look like it, judging by this one. What are you doing, big purple? Come on, swap. Swap, you two. Okay, some of you are really big nodes. I gotta admit. But yeah, there it goes. Okay, so that part's great. Now, yeah, because again, we're being baddies, writing bad codes. Just gonna get this to work. How do I get you a random color? Ah, I shuffle you by your index, then I reshuffle you. Oh, I just hit math random. I, who said math random would never work? Um, Yeah, you just need a number from I to 160 or I to L size. Great, so for cost elf of object values, elf dot color equals math. Nope, that's not what you want. Between, well, not color, number 0 and elf size. Anytime, Copilot. Randomly, thank you. Copilot now. There we go, math for math random. Love that. Now instead of elf color using I, we are using the index. We'll just use the index to else get I. We are indexing by index, right? Good. Yeah, color. Okay, color should be randomized. Oh, it looks nice and random to me. Or did it just randomize the whole thing? We'll find out. Okay, just the colors. Love to see it. Okay, so now we get two approaches. We get the summonation tracking, which will basically just be turning the ones that are small gray and the larger one gold, or we get the small bubble merging. We'll do the tracking since that's actually toward the end. So your color, we're gonna keep track of the largest. Let largest equals null. Very sad. There is no. Well, largest is the first one actually. The largest can be the first one we find. Center of nodes, merged node, new node, and then comes the logic if not largest, or oh, here we go. That's true. So first we want to then if largest, what we want to do is set this color to gray. Ooh. Ooh, that don't look good. That looks dirty. So I don't think we have those query selectors around here. Yeah, we don't have that. Copilot, try again. No, Copilot. Copilot. Okay, we just want to set color attribute. D3 select. No, okay, we want like D3 select largest. Now Copilot, figure it. Style filled gray. Good enough. Then we'll set you style fill. Which one's successful? Green successful. There we go. Green, gray. Drop this weird color. See if that looks right. I haven't really done the non-check, have I? Well, and this value's not really a thing. I mean, merge node does have a value, but I don't think largest merge node. I might. Ooh, it turned black. Great. This style is not defined. Yeah, because largest is just some random objo. We want to talk to new node and not new node value because that's not a thing. New node double underscore data double underscore value versus again double underscore data double underscore value like so. Now this should be D3 stylable. And great, great. This style set properties on a function. Love to see it. Which line was that? Not showing me what line with that. It was do the thing, obviously, but console log largest. See what this is. Let's see what D3 select hates about it. These styles not the way it goes. I mean, it's style fill. It's how they do it. I don't think we need to wait. There we go. Largest 2416. The word largest, and we have the thing, which is groups 0. Come on, you. Group 0, group 0. We're double selecting. Can't select a selection. That's what's up. Things are already a D3 component of. You think that jQuery will be cool if you accidentally double wrap an element, but not D3 apparently. Okay, great. And new node under data is undefined. Well, because you're an array or something, aren't you? Cool, cool, cool. Which means largest is an array, unless I de-array it. Hopefully D3 loves array syntax. Nope. Great, catching this thing into a real array, like this, and then pull out the 0th element. Although largest won't need to do that with, just the new weird one. So largest is already done with it here. Largest styles on a function because we took it out. Ooh, man, which means we need to D3 reselect it. My word. But that means we'll need to take it out when accessing the data again. Man, this juggling is super fun. I think it's just when we need to style it, actually, is when we need to select. So get rid of that. Just the styling. Just when we're styling, folks. Oh, look at that. Okay. It's keeping. See, the green one is always the largest one, folks. Now that gray isn't very gray. I don't know what the heck happened there. Well, look, green, that's the largest one we've got so far. Oh, we found a bigger one. That'd be cool if there was some text on this, but it's cool. There we go. And at the end, there should be like some cool alert or something, but we ain't there yet. But now that we are there, we're gonna be like, ooh, cool, you made it. Largest under data value. Now just for speed, we'll drop this down to 10 to get fast. And now we're zooming. Big setup of the simulation, but not much we can do about it. Oh, look, and since this is ordered, we're seeing the exact same positions. Boop. 74394, which is the answer. I think I messed up the color somewhere. Oh, I didn't set it to gray. No wonder it don't look good. Why ain't there any color? Because I didn't tell her to be any color. Hey, this is going to look better. Might as well give it a run. What happens if I hit early? It literally pauses the simulation. What do you know? I almost feel like I should run my own simulation on this thing, because how painful it is. But yeah, it's definitely better to look at. And for the final cherry on top is the individual merges. So what we're going to do here is while nodes filter, we do get rid of this from nodes, right? It's important. I don't know, we don't get rid of it from nodes, but we do remove it. Hopefully remove, delete. It does look very nice though. Some of them weird ones, but they are acceptable. Come on, node. Move it. Now, yeah, let's go find, while we're here, since we did technically get it completed, though a little tedious at the end there, a Code Wars to finish off the night. Okay, I think that thing is ran enough. And next time, we'll probably polish this off, since I have no visualization ideas for rock, freaking paper, scissors. Okay, console didn't want to run my command. Run the command. There we go. And there it's zooming. That's literally how the code internally runs, so no surprise there, folks. Let's go find us a quick Code War now. Remove screws. This one looks fun. I appreciate that, Neptune. I don't care what label they do, as long as they're paying me, you know, and you can call it whatever you want. Okay, so John is a worker. His job is to remove screws from a machine. There are slotted and cross screws. Has two screwdrivers. The input will be a non-empty string of screws, so symbols. He stands at the first screw with the correct screwdriver in his hand and another in his kit, left to right, removing every screw, switching when necessary. Removing a screw takes a second, moving a screw takes a second, switching takes 5. Return the total taken to remove in seconds. We use A, B, C, D, F to represent screws. The number in brackets are the time in seconds. Remove A, move to B, move B, move to C. Okay, so at the very least, move to D, switch, remove D, move to E, E to F. So every screw costs at least 2, because you have to remove and move. Move to D, remove to... Yes, it's at least... It's just times 2. It's the number of changes that we're calculating. So there's one change, so that's 5. So it's any time the current character and the next character are different, that's how many 5s we add. Okay, I think I got this. So let changes equals 0 for let I equals 0, I less than screws dot length, I plus plus. But we're not going to go to the last character, so -1 if I screws I not equal screws I plus 1 changes plus plus. Now we return screws length times 2 plus changes times 5. I think this will be off by 1 because you don't move to the first one, right? 16, got 17. Yeah, every single one is literally 1 too many because you don't move to the first screw. Bingo. Bango. Matho. And math for you folks. And with that, that is another Code Wars down the drain. I would say they actually did counting all of them, but ooh, hit me with the reduce. Yep, the number of times changed. Nice, 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 nice. Yeah, that was a pretty good one, I'd say. And with that, we will go find someone to raid. I think we see. Let's see what we got. We got Time and Joy. Oh, we got Chrissy Codes. Yeah. Oh, Chrissy Codes is always doing. Oh, wait, I think they're doing Advent of Code. Oh, I think we're ready to fill Advent of Coder. And Chrissy's also fellow friend. Yep, they're definitely. I think that looks like Advent. I gotta open full screen. R sort elves. Yep, they're talking about elves. Unless it's another elf-related problem in the universe, they are doing some Advent of Code. So feel free to head on over there. I'm gonna show them some Phil Advent love. And I will see you tomorrow, sometime after-ish 11 p.m., an hour before the Advent of Code. Well, actually, yeah, tomorrow's Friday. Today's Friday. So I'll see you then, folks. Yeah, Neptune, I appreciate you coming on by. I'm dealing with these rock, paper, scissors. Yeah. Get you next time. Push wrong button. Yeah.